Okay, so chemical changes, chemical properties. We're gonna start with a simple ice pack. All right, we're gonna pour it out. And inside that ice pack is a little baggie, which is what you have to break whenever you smack it, and these little crystals. These little crystals are urea. It's a nitrogen base. It's basically what your urine is made out of, or is the main component of your urine, with some minerals and vitamins and things that have processed through what, depending on what you ate. And so when we break this little package open, hold on, get this set up here. Sorry. All right. So this packet is just water. And so when I put the water in, basically, you know, when you smack the ice pack, you're breaking this little packet and then putting the water in. And that's chemical reaction. One indication that you've had a chemical reaction is a gas being released as well as a temperature change. So in this case, we're bonding the carbon in the urea with, well, actually it'd be nitrogen in this case. Nitrogen in the urea with the oxygen in the water. And so that bonding, we're taking the energy from around to make that bonding take place. And so we have the temperature change of it getting cold. Okay. Another example is, let's see, this is a hot pack, right? This is a little bit different one because it's reusable, right? And it has that little silver disc. That little silver disc is a metal disc, but it's kind of coated in wax, so it's protecting that metal from it being exposed to the gel that's in the pack. And so you bend that little metal disc to kind of break that wax coating and expose the metal to the gel, and you'll see a chemical reaction take place right away. And in this case, we're releasing the thermal energy. So you have a hot, quick temperature change, and you can see that that gel, the chemical reaction with the gel, is crystallizing it. So it crystallizes it pretty quickly, and the temperature gets pretty hot. Now, some of the other the little baggies, and I don't have one with me, but I have the inside of one with me. The little cloth baggies that you shake as a hot hand and you hold it and it lasts for a little while, like 3 or 4 hours, something like that. Inside of those are these little metal pellets, okay? It's actually iron filings. And those iron filings are going to rust. And that rusting process is what creates the hot hands that you're holding. So again, you're having a chemical reaction. The iron is reacting with the oxygen in the air, and that's why it has to be a cloth bag to let the air in, and that's why shaking it exposes more and more of those little pellets to the air, and so it speeds up the rust process. All right, so then the next one would be the match. Okay, we have phosphorus on the end of our match. It's highly reactive, so it's going to heat up with just a little bit of friction. Let's see here if I can get this set up. Sorry. Yeah. I am not the best videographer, obviously. Okay, but I can take a little bit of friction on that match, and it's going to heat up. All right, now the phosphorus burns quickly, so it's already gone, and the wood burns more slowly, so it continues to burn. And we're going to ignite the steel wool in here. Maybe. There you go. All right, and you can see steel or metal typically doesn't burn, but it does have a flash point. And so you're going to have that sparkle. That's actually what's on the outside of sparklers. It's the same thing as what the steel wool is there. And that changes. Guys, you want to step out for a minute because I need to get my mask on. Sorry, no, it's my fault. All right, so anyhow, we have that chemical change where the steel wool is now brittle and blue instead of what it was before. So that kind of sums up our labs for yesterday.